Hello, my name is Pratul Sarma, and this is my final project in Machine Learning Foundations for Product Managers course offered by Coursera. The project involves choosing, building, and evaluating a machine learning model to predict the electrical energy output of a combined cycle power plant. I'll be using part of the DM process to build and evaluate the model. We are given a set of 9,568 hourly average ambient environmental readings as data to use for training, validation, and testing of the model. So the approach I'll be using a multiple regression model, which will be suitable for the project. The output metric to be used is mean standard error. The data set is split into three sets: training set, validation set, and a test set. Training set would be used with a combination of features to shortlist two models for validation. The models will be then validated with the validation set, and the one with the best performance would be selected for final testing. The selected model will be tested using the test set before deployment. So there are four features available in the dataset: temperature, pressure, relative humidity, and exhaust vacuum. And we'll be using a combination of these to predict the output. So during modeling, I performed a regression analysis using an Excel spreadsheet with combinations of these features and noted the correlation between the predicted outputs and actual outputs in each case. So two models were selected based on the best correlation between the predicted output and actual outputs, which are listed below. So the first model used temperature and exhaust vacuum as features. The second model used temperature, pressure, and relative humidity as features. The regression equation is listed here as well. Now let's go to the actual model. I'll give a short demo on how I have done this modeling and also the validation and testing. So with all four features, I ran multiple regression and plotted the output and had the prediction also here in column F. So the multiple R value that basically says 96.43% of the output is correlated to these features used. And the R square value says 92.99% of the output is due to these features, attributable to these features. The standard error is 4.5, which is good. So this is a good model. However, we have lots of data, like four different features, and I have dropped actually some of them to have multiple models, and they went through this training to basically choose those two validation sets. One model where I actually dropped the temperature had actually very bad performance with 10.5 error, so I did not choose that. So now going back to the two validation sets that was chosen, the first one gave optimal performance. The second one also gave similar performance, but even better. So this is the one that will go through the final testing. So this model I ran through the test set and had the data that is even better performance with 4.8 standard error. And this is the one that will be used for final testing and also deployment at the end. So basically, in summary, I have achieved my goal of choosing the validation model and then a final model for testing. And this is what our goal was. So I achieved my goal. And thank you for listening to this presentation.